Okay, next step, like I have mentioned, is here's the TIM virtual machine doesn't connect, right? So we will have to set up the corresponding IP settings in DIATwin. So how do we set it up? Like we back to our DIATwin program. Okay. We have to set up the IP address right here. Okay, set up the IP address right here. So we have the key in 192.168.1.150. And the port for EIP, okay, this is a standard port, is 44818. Okay, please help me to type on these two properties in DIATwin control panel right here. Okay, so you can find here, start simulation, and you can press these two and enable. Okay, so I will do it with AX. So next, now I just start my program, login again. Okay, please, if you have probably this kind of problem, mostly is the coded system have died. So you can use Control-C to terminate the process and restart it again. Okay, so I try again. So call this controlling version 3. Okay, start it again. Yeah, it connect, and you can see the TIM virtual machine is not started, right? So after I start my simulation, okay, and also with our communication plugin, I have typing in the right IP, which is the slave address, and also the port for EIP. And when I start simulation, when I start enable the communication like this, you can see the status of our TIM machine will be green because I have started out the communication checkbox. You can see I terminate it will be red. I start it will be green. Okay, but you have to make sure the IP address and the port is right. Okay, we'll stop. Wait for a while for it. And here is the whole process of it. So if you can remember the process, you can follow up with this video. Okay, like this. I will replay it again. So first, I connect and start the PLC process. You can see the status of TIM virtual machine is disconnected. So when I start in connectivity, I just type in the corresponding address and start simulation. Like this. Okay, 44818 is the standard port of EIP. And next, I just start the simulation. The enable communication. You can see here will be green. And what is next step is we back to the Ethernet IP IO mapping. You can find the EIP table we already constructed. So we can assign the prepare value and press right to control the virtual machine. Okay, I'll show you by my screen right now. You can see back to the, I'll open it again. Okay, here's connected, right? Open the DIATwin virtual machine and switch to the EIP IO mapping settings. Okay, and just expand this variable table. You can see at the top hand side is the corresponding receiver. And now, like if I want to control the join access, you have to scrolling down to show somewhere and to find out the description of the control. Here's the receiver. So maybe output parent. I think it's right here. Right here. Okay, here's the description. So I can use DIATwin at the left hand side Okay, and also the AX software at the right hand side. So when I type in some value right here, like prepared value, when I click 100,000, and we use the right here, right. Oh, sorry, here. Okay, here, right value. Okay, press right value. Here, sorry, right. You can see the value returns, and also the X will move. And also in DIATwin, you can see here's the value already be updated. So as we have shared, one is for manual mode and another is like a remote mode. So we can use this to control, like I will be more larger value. Maybe I switch it to 550,000. Okay, and just write it again. Right. You can see the current value will change. So by this way, you can use your Designer AX to control our virtual machine by changing the value of the IO table. Okay, just key in the value, like if I want to control the Y value, maybe this one. Okay, so I just change the prepare value, maybe 200,000. Okay, and then press right. You can see we can control the axis. Okay, and mostly this value will be updated by in DIATwin. We don't do path planning when updating the value. We just make it snap at the value that you typing in, because mostly in DIA Designer we already have the path planning function, so we do not do any path planning for in DIATwin, just like a XX monitoring way to control the position. Okay, so you can see here is the position, or maybe you can see if the X come in here, it already triggered the limit sensor right here. So I can also check out the value in our limit center right here. Like you can see, here's the link X max limit is 1, right? So it did trigger the signal. Or maybe I can change it another one. I'll put parent right here. Maybe 300,000. Okay, and write again. Okay, after writing, you can see my x-axis moved to here. Okay, so maybe it's not 300,000, it's 30,000. Okay, 30,000. Right. Okay, so I can control it to make it at the origin sensor. So after that, when I check it out with the value right here, you can see the origin sensor signal is true, and the max limit center is off. Okay, by this way, we are able to control it. Okay, and that's today's main operation. And at this section is part we will set. Sorry, oh, this is the stage. Yeah, you just can check out. Okay, and this section is for the actual PLC, but we do not have actual PLC with us, right? So we can just have a quick overview. If you are using the actual PLC, we also have to import the EDS file, and you can see the control now. We have select the actual PLC type, and also we have to add the virtual machine as a slave. Okay, enable the PLC communication, update variable settings. Okay, also set. So this one is the actual PLC's IP address. Okay, it's sent as a send. You can just follow up if you have the actual PLC with you. Okay, so typically the main main process of it is with the same concept. So you can just follow it up if you want to control it with the actual PLC. Okay, so also you can set the TIP virtual machine with the type. Okay, so now when you just start up with the process, and also start the key in the actual related actual IP address. Okay, like this. So this IP is also corresponding with the TIN virtual machine address. Like here is 123. So also you have to set it 123 right here. And here's the demo video of it. It's at this case is we use the actual PLC. Okay, so also we use EIP and to control the XYZ value. We also have the encoder and the motor value to control and receive. Okay, we export the EDS file. So I just do a really quick review for you guys. Okay, please remember to select the DINT format and export the EDS file. And if everyone in today's lecture needs the project of it, you may ask me, okay? So now you can see we also add a project right here. Okay, so we select the actual PLC. Okay, when it's created, we also have to do the every settings. Maybe I will just go through it very fast. It's actually really alike. Okay. So finally, I think you can read this video after today's lecture. I just switch to the back. Okay. So you can also use the IO table to control the values like this. So you can see the tables moves with the same way. But at this stage, we use the actual PLC as the processor, but not the virtual PLC. Okay, and finally, we have the homework for today's lectures. I will quickly do it once. And the homework is like this. We want to use the connectivity to control the conveyor. Okay, so how do we do that? Okay, this is today's homework. Okay. So in our project, we have to find the conveyor, right? So we just also double click again. Okay, so here you can see here track 1 and track 2, right? And also the track 1 and track 2 will be controlled by the conveyor behavior. Okay, that is a concept we already told before. And you can see the conveyor behavior also be controlled by the R02 track 2 and R01 track 1. So these two must be the signal that our PLC have to send the signal with. Okay, so next in the program, I have to connect the lines. Okay, so I didn't know the conveyor want to control, right? So this two is the signal I want. So also I use the PLC, maybe it's AS332-A, like here. So I can use another emitter right here. So maybe I just switch to AS332. Okay, I just changed the emitter name. Okay, maybe this one I can call conveyor. Okay, this is homework. Just please follow up and do it yourself. So you can see here will be a conveyor. So the conveyor signal will control track 1 and track 2 at the same time. Okay, so to make this movable. So you have to construct this table yourself. And next, back to our connectivity settings. Okay, I think it's right here. So for the export settings, we have to add, I'll refresh again. Okay, so you can see here will be a conveyor signal. So we have to add it, okay? And also click it again. So that is what we already trained already. So just add a signal right here. conveyor receiver, where's the emitter? Okay, you can see here we have add another EDS name we call conveyor, and these will be controlled by the emitter. So my actual AX PLC will send the emitter signal to him, sorry, and to X emitter also send the same signal to this conveyor emitter, and the conveyor emitter will control by our IO signal like this, and to control the track. Okay, so maybe I'll do a really quick test. So now I start simulation also. Or maybe you can press apply, but if you want to save your file, you have to remember to press apply, okay? And next, you can see at the control panel, we already have a signal right here, conveyor. So now I just change the data to 1, means true. I just write data. You can see the conveyor is moving. Okay, so by this way, you can also export the EDS file into AX8, and you can find maybe there will be a new IO exchange table right here. So you are able to control the conveyor by the actual PLC or virtual PLC. Yeah, like this. Okay, so that is today's lecture.